Okay, so good evening, everyone. So, once again, welcome to the results announcement session, live session conducted for, sorry, the result announcement session for the Astronomy quiz for Penang Secondary Schools 2022, conducted by Astronomical Society of Penang together with Penang Science Cluster. So, as you know, like last week we have our first round of the quiz, and yesterday, we had our second round, which is the final round, to select 10 individual winners for this quiz. So, yeah, as usual, before we start, all right, we'll have a short discussion session on the selected questions. For this round, we have 10 objective questions and 5 subjective questions. And after the discussion, then we will announce the results. So today the session is estimated to be done within 45 minutes. So without wasting time, all right, tonight with me we have Dr. Chong, President of Astronomical Society of Penang, and me, Lai Hong Jun, all right, a committee member of Astronomical Society of Penang. And the question for final round are set by both of us together with Dr. John Su, a senior lecturer in School of Physics, University Science Malaysia. So let's begin. All right. So Dr. Chong.
Yeah. Thank you, Lai. Just to add on, we would like to thank, of course, the host for this very important announcement. Our society's committee member also, Mr. Michael Teo Chin Cheong. So before I continue, I just to add that some of you may not have attended the announcement for the first round. So basically, the first round a week ago, there were about 62 school teams, Penang school team, and each team three students. And out of that, about 21 students were selected for the second round, which was held yesterday. So today we are going to look at the announcement of the result for these 21 students in the final round. Okay, so look at some of the questions selected. I'll share my screen.
So while waiting, just to remind our students, so if you have any questions you would like to ask or communicate with us, feel free to do so. All right, to comment in the comment section in the Facebook page or also the chat session in the YouTube live.
Yeah, so,
All
right,
right.
can you
So
see my
Dr.
screen
Chong.
now? Right?
Yes, yes,
Okay.
yes.
So Astronomy quiz for Penang Secondary School 2022, conducted by this Astronomical Society of Penang with Penang Science Cluster. So second round was held yesterday, 23rd July 2022. So section A of the second round got 10 objective questions, and section B got 5 subjective questions. All right. So basically, now I will look at section A, not section B, section A, question 4 and 5. Later on, Mr. Lai will talk about the question in subjective question in section B. So this is section A. Okay, question 4. So I read through all the possible answer and then I'll give you the correct answer. Okay, so I don't want to keep you in suspense. Question 4, which of the statements below is completely correct? A, the constellation Ophiuchus lies in the celestial equator, and in it we can find the Little Ghost Planetary Nebula. B, the star Proxima Centauri is a low mass red dwarf star with a surface temperature of 3,500 degrees Kelvin and has 3 known planets. C, Sigma Octantis is called a sub-star in the constellation of Octant, and it's a delta Scuti nebula star with a spectral type of G03. D, the constellation of Hydra is the longest constellation and has a bright star Alpha Hydrae, an orange giant star, and a bright binary star Epsilon Hydrae with an orbital period of 1,000 years and 135 light years for Earth. Now, 1,000 years means that the binary star of 2 stars, they're orbiting around each other. The period of orbital motion is 1,000 years. E, the constellation of Sagittarius has a larger number of Messier objects, 15 Messier objects, 6 globular clusters, 5 open clusters, 3 nebulas, and 1 star cloud. So what is the correct answer? There you are. A and D. A is the constellation of Ophiuchus lies on the celestial equator, and in it we can find the Little Ghost Planetary Nebula. So this is the completely correct answer. The next one correct is D. The constellation of Hydra is the longest constellation and has a bright star Alpha Hydrae, an orange giant star, and a bright binary star Epsilon Hydrae with an orbital period of 1,000 years and 135 years from Earth. So why is this wrong? For B, Proxima Centauri is a low mass red dwarf star with a surface temperature of 3,500 degrees Kelvin and has 3 known exoplanets. So this is wrong. 3,500 is wrong. It is about 3,000 Kelvin. 3 known planets correct, but 3,000 Kelvin. Okay, so this is not correct for this. But C, so Actually, the correct answer, the wrong information is G should be an F. Finland, FO3. The others are correct, except that it's the spectacular FO3. But you put GO here, so it is wrong. Okay, here the Sagittarius is 15 mature objects, correct, but actually it should be 7 globular clusters and 4 open clusters. So 7 globular cluster, 4 open cluster, 3 nebula, and 1 star cloud add up to also 15. Should be 7 globular cluster, 4 open cluster. Okay, that's it. So the correct answer for this part is A and D. All right, question 4. Now we go to question 5, objective question. Before using a telescope with an equatorial mount in Malaysia, we have to do polar alignment with the telescope. Why is it? To do astrophotography. We have to track the stars correctly. Which statement below is the correct polar alignment procedure? A, aligning the telescope polar axis towards the Polaris, the North Star. From Malaysia, remember, from Malaysia. B, tracking the stars using drift alignment. C, plate solving technique. D, 1 star polar alignment. E, 2 star polar alignment. And the correct answers are B, C, and E. Right? Because because when you do the polar alignment, you use the stars using the drift alignment. That means you need to have a high magnification eyepiece, if possible with the illuminated latitude. You look at a star, you bring it to one edge of the field of view, and then you stop the tracking, no more tracking, and you see the way the stars drift, either east or west or north or south. And knowing how they drift, you have to change the azimuth of the tripod horizontally, rotate it until the time, and you after a period of time, usually about for German equatorial mount is about 30 minutes, you'll be able to find that the star eventually is always in the field of view, doesn't drift at all. That's it. But the second one is plate solving method. It's a very popular method, very easy. So basically, you see, let's say you go to anywhere in Malaysia, you see some stars at night, got star. You take a picture of the star field, and then you go and look at a database. Either for internet, there's software, you can do it, or even, for example, you have the Sky 6 software. Previously, now you have the Sky X software, right? For this what you call a telescope mount. So when you put this picture, you took a star and put in the database, it will tell you exactly where is this part, where's the center of the field of view, the exact declination and what you call this right ascension. So this is a plate solving technique, very easy, very popular and very fast. And the E is a two star polar element. Normally, you need to have a polar element at 2 stars in different parts of the sky. You align them, and eventually you find that the tracking of the star is good. The wrong one is aligning the telescope polar axis towards Polaris and the North Star. Suppose you are in the United Kingdom or Japan, you can use the method. But in Malaysia, even in Langkawi, 6 degrees north, the Polaris is about 6 degrees from the horizon, usually blocked by a tree or a building or always got cloud. So we don't use Polaris for polar element. And we seldom use 1 star polar element. So you need a minimum of 2 star polar element to have accurate tracking for your telescope. Okay, so this is the correct answer for objective question for answer 5. Now, problem 5, answer 5. Okay, so I pass it back to Mr. Lai Hong Chun now.
Sorry, Dr. Chong.
Yeah.
Actually, your questions over here are not the updated question.
No,
because that day, remember in the meeting, we already update the questions.
But this is the one I took from my own file, the one I sent to you earlier. So what's
yeah.
What's up?
It's actually we rephrase the questions so maybe I just do a very quick one over here to show the yeah. So this is the original question. Can you see?
Okay, I don't see. Wait. I see your face only. Share your screen.
Wait.
Hang again. Coming. Still hanging?
Wait. Yeah. Can see now?
No, still cannot see. Yes, coming. Looks like coming, but still not coming yet. Now, yes.
All right. So this is the question the students see
Yeah.
Okay. So Yeah. So basically the answer is the same. All right. Just that the question we just rephrase that lah.
Yeah.
Okay.
Okay, thank
Yeah.
you.
So next, okay, we will go to the subjective question. Okay. So let's see. The selected question for the subjective question is question number 4, which is the rocket launch. All right. So let me share my screen for the subjective question. All right, sharing. A moment, please. Okay. So, okay, can you see my screen?
Coming. Yes, I can see. I can read
All
it
right.
well.
So the question is this. All right. A rocket is a common vehicle that used to send spacecraft into space. And the Long March 5, or we call it, sometimes we call it the LM5 or CZ5 rocket, is a Chinese heavy lift launch vehicle that is used to transport large and heavy spacecraft, such as the Tianwen-1 spacecraft, the Chang'e 5 lunar spacecraft, and the Tianhe space station into its desired orbit. And today, it was used this afternoon to launch the Wen-Tian, right, the Wen-Tian space laboratory to dock with the China space station. So the question is here, liquid propellants are the main type of propellant employed in Long March 5 rocket. State the combination of propellant used in the first stage of the rocket and explain whether it's hypergolic or cryogenic propellant. So I was shocked that actually a lot of students leave this question blank because in fact, last week when we have the live session, we actually discussed on the rocket fuel itself. All right, and I did mention that we need an oxidizing agent in the fuel for the combustion to happen. And I actually give the answer directly of this question, which is we need for Long March 5, we use liquid hydrogen and liquid oxygen. All right. So yeah, the main type of propellant employed in Long March 5 is actually uh, this. All right. So liquid oxygen and liquid hydrogen. So for liquid oxygen, if you put LOX, all right, I will give you correct as well. I'll give you marks, all right, because it's a bit upset to see that the marks are too low, and I'm trying to find ways to add marks for our students.
Right,
All
can
right,
you
so
explain what is hypergolic and
wait,
cryogenic?
wait, wait, not there yet, right? So we go step by step, all right? Don't worry, Dr. Jong. Okay. So LOX, all right, liquid oxygen and liquid hydrogen. So initially, my plan is you have to both correct, then you will get marks for this. But then, unfortunately, it seems like most of you get only one correct, which is LOX. So I still give 1 marks for that. But then the question is asking for the main propellant for this rocket. That's basically the core stage. So it's liquid oxygen and liquid hydrogen. I know that if you search Wikipedia for answers, and then you can see that the answers are LOX and kerosene. That is for the booster, but not the main stage. So this is not the main propellant being used. All right. And what type of fuel is this LOX and liquid hydrogen? Is actually cryogenic fuel or cryogenic propellant. You will get marks for that. All right. Because both liquid oxygen and liquid hydrogen, they are required to store at extremely low temperature to maintain in the liquid state. Okay. So for hypergolic propellant are propellant that you do not need to ignite, but when two type of propellant they mix together, all right, combustion will automatically happens. Okay, so that are hypergolic propellants. But for this, the liquid oxygen and liquid hydrogen, both are cryogenic because both have to be stored at very low temperature to maintain a liquid state. All right, so this is question number 14A. And question 14B, okay, uh, using the launch of Tianwen-1 spacecraft as an example. So the Tianwen-1 mission is actually the Mars mission, all right, sending the rover and the orbiter spacecraft to Mars. All right, so list out the flight sequence of Long March 5 rocket accordingly from t equals to 0 seconds until it is injected into Mars transfer orbit. So over here, even though you don't know what is this Tianwen-1 mission, all right, but I already give you the hint over here is a mass transfer orbit, and I still see some students give me the answer that the the spacecraft is injected into low Earth orbit, LEO orbit. All right. So obviously there's something not correct. All right. So before we announce the answers, all right. So maybe we can watch a launch video of this playback. All right, for this Tianwen-1 mission. So this is the video. All right. So basically starting. All right. Counting down. Ignition. So for this rocket, all right, for this Long March 5, the ignition is not T equals to 0. So we count down from 10 to 0 for the ignition, but it's actually 9 seconds before the lift off. So the T equals to 0 start with lift off. All right. So the T equals to 0 starts with lift off. So from T equals to 0, all right, from ignition to T equals to 0, it takes about 9 seconds. All right. So after lift off, it will go to the second step, which is this program maneuver. All right, that means you have to deviate from this original flight path, all right, to change the trajectory of the flight. All right, so the second one is program turn or program maneuver. All right, so if you write turn, you will get part of the marks. All right, you won't get full marks. All right, because it's always automated, it's programmed. Okay, and then at this stage, all right, actually the rocket accelerates, all right. We together using the boosters to accelerate the rocket as fast as possible, all right, because this is the rocket that needs to go to the Mars, all right. So it need to leave the Earth. So you need the escape velocity of the Earth, which is around 11.2 kilometers per second. All right. So at this stage, all right, the rocket have to be accelerated as fast as possible. So the boosters, all right, will accelerate the rocket for about 3 minutes, which is 180 seconds. All right. So the demand on the velocity of the rocket is very high. All right. To make sure that our spacecraft or the Tianwen mission, the Tianwen spacecraft, all right, can escape from the Earth gravity so that it won't be the Earth satellite. All right, it will be the Mars satellite, so it can go to Mars. All right, so it will take about 3 minutes for the boosters, all right, to finish and then finish burning and then jettison. All right, that means drop off. So this is the rocket, all right, observed from ground, all right, and then this is the display screen on the control center. Okay, so this is observed from Earth, all right, from ground. So if you realize this exhaust is actually expanding. Why? Because as the altitude keep on increasing, the increase in altitude, all right, the pressure is lower. So the pressure lower, the surrounding pressure is lower, so the expansion is greater. So all right, the exhaust, all right, you see it will bigger and bigger. And now we are going to see the boosters dropping off, boosters jettison. But before that, the boosters have to turn off, right? All right. Booster turn off, shut down, and then remove. All right, drop away or jettison, booster jettison. All right. So the boosters will drop back onto Earth. All right. So and then the first stage will continue. All right. The first stage is the liquid hydrogen and liquid oxygen. All right. Will continue for a short while. All right. And these boosters, based on the record, it drop back on this South China Sea. All right, South China Sea, which is quite near us, not far away from us. And then this is inside. All right, inside the payload session. So the fairings, all right, are removed. All right, the dropping away the fairings. All right. And then as you can see that a group is a bunch of young scientists actually working on this Tianwen mission. All right. So China's space technology is developing very fast. They have a lot of young people working on this. All right. And then now our Tianwen spacecraft is exposed in the space. All right. So now the first stage is turned off, all right, and then first and second stage separation, all right, first second stage separation, and then the first stage will be drop back to Earth. All right, so this is the successful separation. Okay, and then the second stage continue. Second stage ignite, and then now this is going to do attitude control. That means they are going to adjust the orientation of the spacecraft so that it can be inserted into the Mars orbit. All right. So after this attitude control or attitude adjustment, all right, orientation adjustment. So after that, all right, it will go for the second stage shutdown and then second stage separation. All right. So in a short while, okay. So can you observe over here, right? This is the velocity of the spacecraft, right? It's still increasing. Now it's about 10.3, right? 10.3 kilometer per second. All right. It need to achieve 11.2 kilometers per second to be successfully escaped from Earth. All right, so this is the successful launch. All right, the first and second, the spacecraft and the rocket separation. All right, so this is the image taken from the rocket. All right, this is the payload. All right, and then the second stage separate. All right, so the camera is on the second stage of the rocket. All right, so it's slowly removed. Okay, moving away from the rocket. Okay, so this means that the launch is successful. All right. So yeah, this is it. All right. So this is the whole launch process, and this is the answer. So you have to put this video into words. All right. This 5 minutes video into words. So the answer is over here. All right. So start with lift off and then program turn. So the booster engine cut off and then booster jettison, and then the fairing, the payload or the spacecraft fairing separation, which is this part. All right, will separate, and then the first stage engine cut off, and then the separation, and then second stage engine cut off, then terminal velocity correction, all right, which is the correction you see just now, and then second stage separation, and then it actually have another spacecraft attitude control correction, and only uh, the spacecraft will go into the desired orbit. So this is the answer. All right. So this is the answer for question 14, and that's it. All right. And just for information, so this afternoon actually we are launching the spacecraft, the Wentian Space Lab in to be docked with the international, not the China Space Station. All right. So the launch was this morning, two o'clock. All right. Two o'clock 22. Sorry, 2:22 p.m. All right, so we have a quick playback. All right, so starting with the countdown. Now this is different. All right, different in the sense of this is using Long March 5 rocket, but it's the second variant, which is the Long March 5B. All right, so you realize, all right, first the ignition, and then waters came up to cool down the platform. The first stage will ignite first, and then the booster ignite. All right, and as you see, the exhaust is white color, all right, because these are water vapor, right? These are water vapor, and the citizens, all right, the public is actually observing from the beach on this Haikou, all right, in this Haikou, in this near this Wenchang Launch Satellite Center, satellite launch center. So this is carrying the whole top part over here is actually the payload, all right. It's 20.5 meter. Right, it's very big. This is a single stage, different from the Long March 5 itself. This Long March 5B is a single stage rocket. Okay, single stage rocket. So similarly, all right, after about this is the camera outside the rocket. All right, taking on the first stage. Okay, capturing the image of the boosters. So about 3 minutes, the all right, so can you see it actually just exceed the sonic boom just now, and the boosters will shut down, engine cut off, and then it will jettison. That means it will be detached from the rocket main body and then return to Earth. All right, so we just fast forward. So yeah, so the boosters is still here, right? Okay, so you see, about 3 minutes, the boosters is about finish its job. So yeah, engine cut off. All right, engine cut off, and then jettison. Why we need to throw away these boosters is because after it finish burning, that means it finished its job. If we are still continue to carrying the boosters together with us, then it will actually just a weight, all right, a load to the rocket. So to lighten the load or the weight of the rocket so that it can go faster, we have to throw the boosters away, and the fairing is going to open. All right. So this part, all right, this part is actually the space lab, right? The space lab that going to be docked with the China space station. All right. So we fast forward. All right. The fairings have been removed. All right. Jettison. All right. Returning to Earth. And yeah, the first stage is still continuing. All right. Because this is a single stage. All right. Only one stage. We only have first stage. So it will continue. All right. It will continue burning for some time. All right. And then, yeah.
And this goes into Earth orbit, not go to Mars.
Yes,
Earth
this
orbit.
one is the one that goes to low orbit, low Earth orbit, not going to Mars. So if the student who write for this one going to low Earth orbit, then you will get marks for that. But unfortunately, the question just now, I'm sorry, you did not go for that. All right. So basically, this is it. All right. It launched and goes into space, and then the separation. Okay. So yeah, that's all for the question discussion today. All right. So let me stop
The
presenting.
results, right? The results. They are
Yes.
waiting and waiting.
So this is about the time for us to start discussing the results. Okay. So let me change the slide. Sorry.
Yes.
1 minute. I have to on the. Okay. So let me share screen. So yeah, this is the time that most of our students are waiting for. All right. So let me share screen. So now is the time. Okay. So Dr. Chong, can you see my screen?
I can see you. I can see your screen. I can hear you also. Nice. Excellent.
Okay. All right. So 2022, Penang State. All right, Penang State Secondary School Astronomy Quiz Competition, second round, which is the final round results announcement. All right. So let's start. So today we are going to announce the individual winners. There are basically 10 participants being the highest score from the second round are selected. We have 5 main prizes and 5 consolation prizes. So we will start with announcing the consolation prizes. All right. The first consolation prizes, all right, goes to Nur Shafia Afika binti Zulkifli from SMK Tinggi Bukit Mertajam with the score of 16.5 over 120. All right. So congratulations to Nur Shafia Afika binti Zulkifli. Next, the second consolation prize goes to Jolene Goi Liu Yi from SM Chongling Private. The score is 20 over 120. So once again, congratulations to Jolene Goi Liu Yi. Okay, the third consolation prizes goes to Lee Ken Hee from Straits International School Penang. He have the score of 24 over 120. So congratulations, Lee Ken Hee. Right, well done. Next, we have Su Zizie from SMK Tam with a score of 28 over 120. So congratulations, Su Zizie. Right, and the last consolation prize goes to Aiswarya AP Yesudas from SMK Tinggi Bukit Mertajam. Right, she scored 36 over 120. So congratulations to Aiswarya And also, once again, congratulations to all our Consolation Prize winners. All right. So these are the Consolation Prizes. All right. Next, we go to the fifth prize, the fifth place. All right. Fifth prize. So the fifth prize goes to Tan Ivan from SMK Chongling. All right. He scored 38 over 100 and over 120. All right. So well done, Tan Ivan. So congratulations. Next. All right. We go to the next one, the fourth place. All right. The fourth prize. The fourth prize goes to fourth prize goes to Talent Ko Wei Jie from SM Chongling Private. All right, he scored 40 over 120. All right, so 40 over 120. Congratulations, Talent Ko Wei Jie. All right, good job. All right, doing well, doing quite well. All right, so to win the third prize, all right, you need to have the marks, the score higher than 40. Okay, higher than 40. So if you have confidence with your score, right? So maybe you can tell us through the chat session or the comment session in the Facebook Live or the YouTube channel, right? We see who have confidence to win the third prize, all right? So let's see, third prize. Third prize, all right? So we need some music, third prize.
Yes.
All right. So the third prize goes to Chia Yu Xuan from SMK Itam. She scored 44.5 over 120. See? Okay, so congratulations, Chia Yu Xuan. All right, well done. So next, we have the second prize. All right, so second prize, you have to be higher than 44.5. All right, even though it's not even half of the total score. All right. So next we go to the second prize. So who is the winner for second prize? So the second prize goes to Ng Kin Him from SMK Chongling. He scored 45 over 120. All right, so congratulations, Ng Kim Him. All right, good job and well done. Okay, now we are going for the first prize. All right, the first prize. Okay, so who is the winner for the first prize? Okay, the first prize goes to Liu Zewei from SMK Chongling. He also scored 45 or 120. All right. So there's actually a tie between Liu Zewei and Ng Kim Hin. Right. Both of them score 45 or 120. But the tiebreaker is on section B. All right. So the person who score higher marks on section B will win, will get a higher rank. So congratulations to Zewei. All right. He have a higher marks in the section B. So congratulations to Zewei for being the first prize winner for this astronomy quiz. All right, good job and well done. And once again, congratulations to all of our winners. All right, you are doing a good job. All right, and we sincerely hope that you all learn something from this quiz. All right, so once again, congratulations to all winners. Dr. Chong, any comments?
So congratulations to everyone. All right. So although you look at the score upon the total score, leaves quite a lot of room for improvement. But it shows that our Penang students are putting the effort. All right. So we hope our Penang students will do even better in future. And of course, not forgetting that they are taking part also Penang students in International Astronomy Olympiad, you know. All right. So it's a good exposure. So work hard. All right. And even more success in the future. Okay. So we are from the Astro Society of Penang and the Penang Science Cluster. Thank you, Mr. Lai, and thank you, Michael Teo, also. Yeah. Any question they ask, Lai?
From the Facebook side, I don't see any.
Yeah.
Let's see from the YouTube side. All right. So 1 minute. Let's see whether any from the YouTube side. Sorry, 1 minute. Just let me check the YouTube side. All right. So I don't see,
Mm,
yeah, I don't see
mm.
any comments or any questions from the YouTube side. All right. So I think that's basically all about it. All right.
So
So
maybe Michael, you can announce when you are going to send the prizes to them and also the certificates of participation. Yeah.
actually I have just a comment. All right. So in fact, this time, all right, the even the first prize winner, the score is not exceed half of the total marks. All right. So actually, we are hoping in future, all right, slowly developing our astronomical education in Penang. Slowly we will have a higher performance students in this quiz, all right? And hopefully one day, even in the second round, we can have students with higher scores on this astronomy quiz, all right? So any suggestion or any advice from Dr. Chong to our students?
Yeah. So I think over the years, there's quite a lot of awareness amongst our Penang secondary schools, especially the quiz we hold and also the International Astro Olympiad. And even in primary school now, we have done a few times primary school, the especially the face-to-face in Bengtek Primary School. So I think Penang is on the correct path. So now what? Work harder, all right? So basically, we are going to do here in our quiz, we are not comparing what you learn in your school astronomy. We are actually going higher level. So we are actually trying to come up to a level which is hopefully, in terms of the astronomy quiz preparation, equal to even actually international competition standard. That's what we want. Pay attention, right? Pay attention. Yeah. So maybe in future, I will suggest to Lai and Michael that we not only do the theory, basically these 2 rounds is mainly on theory. Later, we need some practical also. Like in the Interest Olympiad, they actually have to handle telescope in front of us. Test them. Look at the sky. What constellation? They must point at the correct constellation. Practical also. We hope to bring in this practical component, if possible, in the future quizzes. When we are hopefully next year, face-to-face quiz competition. Yeah.
Yes, and yes, there is students commenting, suggesting that the time given for this quiz is too short. So yes, actually, this is done intentionally. All right. So because this quiz this time is online, so one of the method to avoid students from searching the answer online or any other source is by limiting the time. So you need to know the answers to answer all the questions instead of giving you some time for you that able to search for answers from the internet. All right. So this is why we are giving a very short time this time. All right. If this is a face-to-face, if this is a face-to-face or a physical quiz session, then the time given will be long, so that you have enough time to write and think and write. But this time, because this is online, so this is one of the precaution steps we conducted to avoid students from cheating, to reduce the possibility of students cheating in the quiz.
But
Right?
at the same time, Lai, I look at those people answering my question, both in the objective part of round two and the subject part of round two. They actually have no marks for that whole part. There are 5 small parts. All the parts are all zero. So it shows that the student most likely don't even understand the question and don't even know how to think of how to approach it. They don't even. I mean, they don't have enough what they call deep enough training for different topics. So that means there are wide gaps of not knowing in the astronomy. But if you really do it, you try to cover all the gaps so that practically all the topic you have some idea, you know quite well. So for some students, there are wide gaps in their knowledge they don't know anything about. So you have to cover the gap by reading more, by helping yourself more. All right? Yeah.
Yeah. So for this year, all right, we have the second astronomy quiz for secondary schools. All right, next will be for primary schools. So for those who wish to have another attempt, all right, we see you 2 years later, which is in 2024.
Yes.
All right. So you have 1 more year to prepare. All right. Study hard. All right. Read more astronomy books, astronomy magazines. All right. Or try to communicate with us. All right. To learn more about astronomy, and then join us again in 2022 for the next astronomy quiz for secondary schools. All right.
So what
So once,
I just have one more
oh,
final.
sorry, 2024.
Yeah.
Yes.
One more final advice is So we are still, as a society of Penang, we are now starting after the pandemic. Saturday night stargazing in Kapasing Drive, 9 p.m., like the previous one yesterday. All right. So we hope that for those students in the first round or second round, you want to learn about practical. Come to Kapasing Drive Saturday night. We have our group, our members group of the society, and also the Voyager of the New Horizon. Or maybe you can see our Facebook. So Saturday night, stargazing, Kapasing Drive, 9 p.m. near the Four Pillars. Free of charge. Can come. So come and join us. So we train you a lot on the practical aspect of astronomy. Yes.
Yeah, both practical and theories are equally important.
Yes, yes.
All right. Not only say you are good in theory and then you don't know how to do practical.
Yes, yes.
That's not enough. Or you are good in practical, but you don't know anything about theory. It also don't reflects that you are good enough in astronomy. So both are equally important. All right. So thank you everyone. So we will see you all in 2024 and the results. All right. The results will be posted in our Facebook page. All right. So if you missed the result announcement just now, all right, you can look through our Facebook page. All right. We will post the results over there.
And also in our YouTube channel a bit later.
Yeah, there's a playback. All right. You can also watch the playback on the question discussion on the question on the selected questions. All right. So yeah, that's all for today. So anything else before we end the session?
Thank you very much, Lai. Thank you to Michael, and of course in the background, thank you to Dr. John Su of USN. Yeah.
Yeah, also thank you Penang Science Cluster for supporting us
yes.
in conducting this quiz.
Yes,
All right.
yes.
Also thank you to the University Science Malaysia USM students in helping us for the first round invigilation for the quiz. All right. So thank you everyone, and thank you all students. We see you again in 2024.
Yeah.
All right. And we hope in 2024, all right, everyone can do better. All right. Have a higher achievement in the quiz.
Yes.
All right. So thank you everyone, and have a good night.
Yeah.
Bye bye.
Good night. Bye bye.